Hello? Am I audible?
Hello, ma'am.
Good afternoon, everybody.
Ma'am,
Yes. Rani
Good
Banur,
morning,
am
ma'am.
I audible?
Yes, ma'am. Yes, ma'am. Good
Oh, okay. Dharwad?
morning. Audible, ma'am.
Yes. Why very few students in Dharwad? Very few, right? Yes. Chikkodi?
yes,
Okay,
ma'am.
fine. Yes. Thank you. I
They
got to know that I am
reiterated.
audible. Okay, fine.
Good afternoon, ma'am.
Good
Yes.
afternoon, ma'am.
Yes. Very good afternoon, everybody. Uh, do I have to ask you who is this? I
Vijay
mean,
Mallya.
Alva, yaridu?
Vijay Mallya. Chikkodi.
ಇದು ಯಾರು ಗೊತ್ತಾಗ್ತಿಲ್ವಾ? You don't know
Vijay
who
Mallya.
this? Ah, yes, correct. Vijay Mallya. And I think
Vijay
this I have to
Mallya.
ask you, Vijay Mallya, yes. This I have to ask you which chapter we were doing. I just want to check whether you remember or not. Which chapter are we doing?
Coordination compound.
ನಂಗೆ ಗೊತ್ತಿತ್ತು ಒಂದು
Chemical
ಚೆನ್ನಾಗಿ
kinetics.
ಗೊತ್ತು right, we had
Good.
already started with chemical kinetics. One session was over and some of you are still in that coordination compound chapter, right? Yes, so we had started with chemical kinetics, and I remember in the previous session we discussed very basic question, how to write the rate expression, and what happens if for the rate of a reaction if the concentration of some of the reactants is changed. So we discussed several such kind of question. So just to recollect all those things whatever we discussed, I have few questions which are related to previous class discussion. Okay, you try to answer this, then we can move on to next concept. Let us begin with this question.
Option C, ma'am.
Option C, okay. Others? This is not difficult. Only one of you have answered. What about others?
Option A, ma'am.
Option A. Hmm. Okay. Let us check. But you are taking a lot of time for this. Others, no, only two of you have answered till now. This is not a difficult one. So whenever you get such kind of question, the relation between this and that, what you have to do basically, you have to write the that rate expression, the integrated rate expression of this. Okay, rate expression ಹೇಗೆ ಬರುತ್ತೀರಾ? -1/2. In previous session we discussed all about this only, alva? How to write rate expression. NO2 by dt is equal to by dt. So here they have given us this few data. ಏನು ಹೇಳಿದರೆ this negative dN2O5 by dt, this entire thing, this is nothing but K1 into N2O5. So we will substitute that over here. K1 N2O5 is equal to 1/4 this entire part NO2 by dt. ಇದನ್ನೇನಂತ ತಗೊಂಡಿದ್ದಾರೆ? They have taken it as K2, and dO2 by dt they have taken it as this. Now all these are same alva, I can cancel this out. Same ಆಯಿತು. ಈಗೇನಾಗುತ್ತೆ? 1/2 K1 is equal to 1 by 4 K2 is equal to K3. Aita? So what you have to do, because we don't have this kind of relation given over here in our option. So what should we do in this case? You multiply this one by the largest denominator that you have. The largest denominator that I have is 4. I will multiply this by 4. What do I get? 4 by 2, 2 K1. 4 by 4, K2 is equal to 4 K3. Right? You will get this as the correct expression. Where do we have?
B.
Option B. 2K1 is equal to K2 is equal to 4K3. Alva? Correct ಇದೆ. Option B. This is how you do. ಆಯ್ತಾ? ಈ last part ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ how to do ಅಂತ. Option B is correct. Next. This one. Rate law you have to find out using the given data. They have given the expression, the reaction. So you can eliminate one of the option easily by looking at the question. ಅಲ್ಲೇ ಒಂದು option eliminate ಮಾಡ್ಬೋದು.
C eliminate.
C you're going to eliminate, okay.
Option A.
Option C.
Option A, option C. Answer everybody with your cue
Option
card,
D.
everybody. Okay, fine. Cue card result can I get? Everybody, Ranebannur, everybody. Chikkodi, Dharwad. So I first told you to eliminate, right? Two options you can eliminate. I would say you can eliminate option B and D. How am I saying that? I am observing this last statement. Doubling the concentration of B has no effect on the rate. If a particular concentration, if it has no effect, means that concentration term will not be involved in the rate law. You cannot include that concentration term in rate law. That means as B doesn't have any effect on the rate, I will not include B in the rate law. In option B and D, they have included B in the rate law. That is why I am eliminating B and D. So now, how does the concentration of E2 and C affects? We should think about that, Alva. We don't have to find out both case. We will find out only one case. I will look, C is same in both the case, Alva. The change is only with A2. We will check what is happening with the A2 concentration. First statement nodi, tripling the concentration of A2 triples the rate, Alva. Iga, if I take the rate as something like this, okay, I don't know how the rate is affected by A2 concentration. What is the power? I don't know that. I don't know that. I will take it as X. Okay. Now what they are doing, they are tripling the concentration of A2. What can I write in the second rate expression? R2 is equal to K into triple the concentration of A2. Triple the concentration of A2 to the power X. Now they have said tripling the concentration of A2 will triple the rate. That means R2 is equal to 3R1. The rate in the second case, it is 3 times the rate in the first case. It has become 3 times the rate of first case. So I have taken R2 is equal to 3R1. I will substitute this over here. I will get 3R1 right. So 3R1 is equal to, I can take this as 3 power x and A2 power x. I can separate that alva, product there, A2 power x and k as it is. Now this entire term k A2 power x, it is nothing but what? R1. So I will substitute this by R1. Avag ಏನು ಬರುತ್ತೆ? So what can I do now? I can cancel out R1, R1. So I end up having 3 is equal to 3 power x. 3 andre enu 3 power 1 anta I can take. So now these base are same, then I can equate their powers. That means x is equal to 1. X is equal to 1. In this rate expression, R is equal to k into A2 power 1 barbeku. But here they have given A2 power 2. So obviously this is not possible. It has to be C. It has to be C. You can again find out for C whether it is 1 or not. You can find out using this, but no need to do that. Why do we have to waste our time, right? The C is same in both the option. The only change is with respect to A2. Now we have found out A2. A2 to the power 1 should be there, and we have that in option C. Directly go with option C. Okay, ಈ ಪವರ್ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು? This is how you find out. You have to practice this kind of question. This is very important. Aita? So I hope you understood how I took all these things. Understood everybody? Shall I give you one more similar kind of question? Yes? Any doubt in this? Any doubt? Ranebenno students, Chikkodi?
No, ma'am.
No? I'll give you one more question which is related to this. You people try this. This one. Try this. Overall order of a reaction. What is the overall order?
Option C.
Option C. Okay. So this is very easy, look. First of all, what we'll do, we'll write the rate expression for this. How do we do that?
Option C.
Rate is equal to K into concentration of A, concentration of B. Now if you are taking the concentration of B as 2, then you are wrong. Don't do that. Because this order, the power, you cannot directly take from the given stoichiometric reaction. That is an experimental determined quantity. We don't know what is the power of A and B as of now. We will take it as some X and Y. Fine. Now the rate constant value they have given, that is K, which is 2 into 10 power minus 3. And concentration of A and B, they have taken it as 0.3. So we'll take it as 0.3 y. And rate also they have given, that is this.
Into 10 raised to minus 4.
Alva. Now what I can do, I'll take this over here, denominator. I'll take this to the denominator. 6 10 power minus 4 2 into 10 power minus 3 is equal to this here, the base is same, which is 0.3. Then I can add the powers alva, ಏನಾಗುತ್ತೆ x plus y ಆಯಿತು. ಈಗ ಇಲ್ಲೇನು ಮಾಡ್ಬೋದು, here we can cancel out few things, right? 2 1s are 2 3s are. And if I take 10 power minus 3 to the numerator, it will become 10 power plus 3, right? So 10 power plus 3, the plus 3 and minus 4, it will give what? Minus 4 plus 3, minus 1. So I can write this as 3 into 10 power minus 1, which is equal to 3 into 10 power minus 1. It is nothing but what? 0.3. Alva, 0.3 na ee riti baribodu alva. So 0.3 to the power 1, 0.3 to the power x plus y. Here base is again same. We can equate this x plus y to 1. So how do you give the definition of order? You say it is the sum of the power of concentration term. Alva? Ide sum nanige ಏನು ಬರ್ತದೆ? I am getting it as 1. That means the order of reaction, it is nothing but 1. Option C. Okay, so the common mistake that I see students doing is that they take b to the power 2 something, which is wrong. Don't do that. Aita? So this is the correct way. Try this question. So they have given this inferences from this data. Now whether these are correct or not, you have to find out which statement is correct. That is what you have to find out.
Option C, ma'am.
Option C, okay.
Option B, ma'am.
B, first and second only. So if you find out whether this is correct, you will know whether the other two statements are correct or not. So first thing that you have to do is whether the rate law is the correct one or not. Okay, option C you're going with 2 and 3. So I am going to check whether this is correct or not. Now according to this rate expression, so if you see this expression, what is this expression saying? That rate is first order with respect to A, alva il 1 power ide. It is also first order with respect to B. Total order kelta illa with respect to each concentration term. It is first order with respect to A, it is first order with respect to B. Alva? Now one thing, if it is first order with respect to A or B, if it is first order with respect to one of the concentration, what do we observe over here? What should we observe over here? If A doubles, rate also doubles. Alva? In the same way, if the rate is first order with respect to B, if the concentration of B doubles, the rate should also double. So that is what we have to check over here. We have to check whether it is actually first order or not. So hege, first I will take these two, 1 and 2 data. Here what they have done, they have kept the concentration of B as constant. They are changing the concentration of A. Now they have changed the concentration, they have doubled the concentration of A. When they double the concentration of A, what is happening to the rate? Rate also got doubled. Alva, it was 2 earlier, now it is 4. So doubling the concentration of A, if it doubles the rate, then you can say rate is first order. It is first order with respect to A. So this is correct. It is first order with respect to A. Now we shall check the second one, whether it is actually first order with respect to B or not. For that, we'll check this 2 and 3 data. What is happening? They have kept the concentration of A constant. They are doubling the concentration of B. Alva, 2 in the 4 madudru. What is happening to rate? Rate is also getting double. It is, it is changing from 4 to 8. That means when I double the concentration of B, the rate is also getting doubled. Now I can say that with respect to B, it is also first order. So whatever the rate expression they have given, it is correct. The statement 2 is correct. Okay. Now we'll check whether the third is correct or not. Rate of reaction increases 4 times on doubling the concentration of both. Now what is happening? I'll take the second rate where I have doubled both A and B. It becomes 2A and 2B. I can take this as 2 into 2 ಏನಾಯಿತು 4 4 KAB. Now this 4 KAB, this is nothing but this alva. I'll take this as R1. I can substitute this as first rate, which is 4 into R1. So what are we observing? When I double the concentration of both reactant, I see the rate is increasing by 4 times than the first one. So this is also correct. So 2 and 3 correct anta gottaytu. What about the first one? They're telling us about the rate constant. So now we have to check whether this value is correct or not. How do we do that? You can take any of the 3 data. You will get the same value, okay? I will take this data. To find out rate constant, again we have to rely on this expression. R andre eno rate. I will take this data. According to this data, what is the rate? 2 alva. 2 into 10 power minus 4 is equal to K is rate constant, which is what I have to find out. I'll take it as K. Into concentration of A, what is given? 1 into 10 power minus 2. And concentration of B, what they have given? 2 into 10 power minus 2. So idenaytu 2 into 1 2 into 10 power minus 2 10 power minus 2, you add the power, it will become minus 4 alva. So that means I can cancel these two. 2 into 10 power minus 4, 2 into 10 power minus 4. What is the value of K that you get? K is equal to 1, only 1. But here they have given what? 10 power minus 4 also they have included, which is wrong. This is wrong statement, okay? The only correct statement is option C, 3 and 2. Aita? This is how you find out. Next. Try this. Based on first order rate constant equation. I had given you the equation in the previous session. Use that and try to find out the answer.
C, ma'am.
Option A, okay.
Option C, ma'am.
C na, ha.
Option C, ma'am.
Fine.
Second one, ma'am.
Second one. Okay.
Ma'am, option C.
C. So they have clearly given first order. What is the expression for first order? Idalva. Somebody takes, some people take R naught by R, everything is same. I take A naught by A. Now the time is given as 24. 2.3 not D.
24
So
minutes.
A ಮತ್ತೆ B ಮೊದಲೇ eliminate ಮಾಡ್ತೀವಿ. So it has to be either C or D divided by 24
Yes, ma'am.
log of initial, let us keep it as A naught only. The final A ಏನು ಹೇಳ್ತಾರೆ, it is reduced to 1 by 8 of its initial value. That means A is equal to 1 by 8 of A naught. A is equal to 1 by 8 of A naught. So ನೀವೇನಂತ ಹೇಳ್ತೀರಾ, you take it like this, 1 by 8 of A naught. So A naught you will cancel. 1 by 8 and you can take it as 8 alva. So it will be log 8 So this is the expression, and since
Option
you have
D.
taken it as minute, it will become minute inverse. Option D is correct.
E, ma'am.
Okay, option D is the correct one. Next, this one. What percentage will be left after 240 minutes?
Option second one or fourth one, ma'am.
Huh? Sorry? Half-life they have given, first order they have given. You don't have to take the half-life expression to find out the answer for this, I'm telling you. You have to take the rate constant expression of first order, and using that you can find out the answer. So you're finding it difficult? Not answering, nobody? Fine. We'll start with the first statement. The half period of a first order is 60 minutes anta helidare. Now when I take this expression, of first order reaction, half period means the time taken, what do you mean by half life or half life period? Half of the reaction to complete, right? The time taken to half of the reaction to complete, ಅದು ಅಷ್ಟು half ಅಷ್ಟು ಕನ್ವರ್ಟ್ ಆಗಬೇಕು ನಮ್ಮ ರಿಯಾಕ್ಟೆಂಟ್. ಅದನ್ನ ನಾವೇನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೋದು, ಐ ಕ್ಯಾನ್ ಟೇಕ್ ದಿಸ್ ಟಿ ಆಸ್ ಟಿ ಹಾಫ್, ರೈಟ್? ದಿಸ್ ಟಿ ಹಾಫ್ ಇಟ್ ಇಸ್ ಗಿವನ್ ಆಸ್ ವಾಟ್? 60 minutes.
60 minutes.
They have given t half as 60 minutes. When I'm taking this for half life, I will take it as t half. And ಟಿ ಹಾಫ್ ಆಗ್ತಿದೆ ಅಂದರೆ ದಿ ಎ ವ್ಯಾಲ್ಯೂ ಏನಾಗಬೇಕು? The amount, it is reduced to half of the initial value. A will be equal to A naught by 2, right? So I will substitute that over here. ಅವಾಗ ಏನಾಗುತ್ತೆ? Log of A naught by 2. So ಇದೇನಾಯಿತು? A naught cancel, 2 I can take this to the numerator. So I have taken out, or I have found out this expression for rate constant using the first data. Now they are asking us what percentage will be left over after 240 minutes. What are they asking? What do we have to find out over here? Now when you take the rate constant expression, this is time taken, this is the rate constant, this is the initial concentration, this is the final amount that is left, alva? So that is what they're asking us to find out. Percentage will be left out. So they are asking us to find out the value of A, right? Now T value ಏನು ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ? They have given 240 and K value just now we have found out. So what we'll do, we'll rearrange this expression for this log of A naught by A. Log of A naught by A, it is equal to K into T divided by 2.303. Right? So K value we know, we'll go to this entire thing is K value. We'll substitute that. 2.303 by 60 log 2. Don't substitute the value of log 2 yet. We'll do that later. T value 240 divided by this 2.303. Okay, this entire thing is K value, 240 given and 2.303 I have over here. So now what can I do? I can eliminate these two. Cancel. 61s are 64 4s are. Alva. Now what do we have? We get log of A naught by A equals to 4 into log 2. So ಇದು ಹೇಗಿದೆ? M log n ಅಂತ ಇದೆ. How can I write this? I can write this as log of 2 power 4 ಅಲ್ವಾ? log of 2 power 4 ನೀವು ಈ ಥರ ಬರೀತಿದ್ರಿ ಅಲ್ಲ log ಅಲ್ಲಿ. So m log n ಇದ್ರೆ you can take it as log m power n. That's what I did, log 2 power 4. Now what do we have? We have this. I'll write here, the next part I'm going to continue here. We have log A naught by A is equal to log 2 power 4. The log same ide, you cancel it out. You get A naught by A is equal to 2 power 4. What is 2 power 4? What is 2 power 4? 2 power 4 ಏನು? Simple
60.
math. 16. Alva. So now we have A naught by A is equal to 16. Now they're asking us in percentage. Now it is even more easier. What we'll do, the initial A naught, let A naught be 100. Okay, on 100 gram ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ, 100 ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. A we don't know is equal to 16. Now A will be equal to 100 by 16. ಎಷ್ಟು ಬರುತ್ತೆ 100 by 16? ಸಿಂಪಲ್ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿ.
6.25.
6 96 ಬರುತ್ತೆ. ಎಸ್ 2 32. ಎಸ್ 6.25 ಅಲ್ವಾ? ಸೊ ಈಸಿಲಿ ಯು ಕ್ಯಾನ್ ಫೈಂಡ್ ಔಟ್ ಇಟ್ ಇಸ್ 6.25%. ವಾಟ್ ಪರ್ಸೆಂಟೇಜ್ ಅಂತ ಕೇಳಿರೋದ್ರಿಂದ 6.25. ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ಯು ಡೂ ಇಟ್. ಸೊ ಯು ಟೇಕ್ ಔಟ್ ದಿ ಕೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫ್ರಮ್ ದಿ ಹಾಫ್ ಲೈಫ್ ಡೇಟಾ and then you put that K expression over here for the given time. Then you will get this. Option A is correct. Okay. Next, this one. One concept, if you apply, you'll get the answer for this question. Rate they have given. What is happening with the volume and how does volume affect the concentration? So you have to analyze that. Okay, try answering this. Everybody give me a cue card answer. No much calculation required. Very simple. So what are they actually doing? The volume occupied by reacting gases is suddenly reduced to half the original volume. So one thing you have to remember, okay, if volume is reduced by half, concentration gets doubled. Volume and concentration, they are inversely proportional. So you remember this point. So this is important because similar kind of question has been asked in previous year also. So this relation you should remember. If you are increasing volume, concentration decreases. If you are decreasing volume, the concentration increases. Now what are they doing? They're reducing the volume by half. Then obviously the concentration of each reacting species, it is getting doubled because they're reducing the volume of each reacting species by half. So the first rate expression was this. Now what is happening? I am reducing the volume. That means I have to double the concentration. I have to double the concentration. This is R1. In second case, the concentration of each species is getting doubled. 2A, 2B. What can you do now? 2 into 2, 4. 4K A B into R2. This entire thing, it is again what? R1. What can I write? R2 is equal to 4 R1. So the rate increases by 4 times when you are reducing the volume by half of each of the species. So this one you remember. Option D is correct. 4 R1. Aita? This question, direct question, depends upon rate constant of a reaction. It depends upon.
Option A, ma'am.
Option A, yes.
Yes, ma'am.
Ha. Very good, very good. That is correct. It
A.
depends upon temperature, okay? The rate constant of any kind of reaction you take first order, any zero order, yadadru tagoli, the rate constant, it always depends on temperature. ನೀವು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಚೇಂಜ್ ಮಾಡಿ ಟೈಮ್ ಚೇಂಜ್ ಮಾಡಿ ಯಾವುದ್ರಲ್ಲೂ it ಡಿಪೆಂಡ್ ಆಗಲ್ಲ. It depends on the temperature. ಇದು ನೆನ್ಪಿಡ್ಕೋಬೇಕು, this fact, okay? Option A is correct. Good. That was quick. Next. Can you answer this? molecularity is only applicable for elementary reaction, rate law. Notice they have given four different statement, which is
Option D,
incorrect.
ma'am.
Huh?
Option A, ma'am.
Option A.
Option A, ma'am.
Option A statement, it is actually correct. Molecularity is actually applicable for elementary reaction. Elementary means the one which happens in single step.
Option
If you
D,
have a
ma'am.
single step reaction, you can say
Option
molecularity.
D.
When it is complex reaction, multi-step, then you cannot say molecularity directly, right? So this is an incorrect statement. Rate law for any reaction cannot be determined experimentally. This is wrong. Actually, it is determined experimentally only. Alva ನೀವು order ಎಲ್ಲ ಹೇಳೋದು ಹೇಗೆ?
Yes,
By
ma'am.
experiment. So this is an incorrect statement. Option B is correct. Okay, fine. So today we'll wind up at this point. Tomorrow we'll continue with this similar kind of concept, and we'll discuss the last part of chemical kinetics tomorrow. Okay, thank you students then. Bye bye.
Bye, ma'am. Bye,
Bye,
ma'am.
ma'am. अभिषेक बंटल